Okay, I think we're good to go. So let's start. Hello, everyone, and welcome to our webinar tonight. I must say I'm really overwhelmed to see that so many of you are joining tonight. To be part of this interactive journey on how to migrate 100 clusters from on-prem to Google Cloud without downtime. My name is Caroline, and yeah, I must say I'm very happy that this topic is generating so much attention and awakening a lot of interest. That is really awesome. Our speakers for today's webinar are Manuel, who works as a systems architect at Kubermatic, and Toby, our senior solutions engineer. And together they will be walking you through the differences of migrating 1 or 100 clusters with productive workloads. And they will be discussing what parts can already be automated and what steps still need to be done manually. Before we can start with the exciting part, I'd like to make 2 more comments. If you have any questions during the presentation, please use the Q&A chat window below so that we either can answer them straight away or in the Q&A session right after the talk. And in case you need to drop out earlier, no worries, we are recording the session and we will send out the replay in the coming days. We will upload it to our YouTube channel so you can watch it whenever it suits you. That's it from my side. So I hope you'll enjoy it, have fun, and now handing over to Manuel, the stage is yours.
Thanks, Caro. Hi, so welcome to our webinar, how to migrate 100 clusters to GCP without downtime. That's a fun topic. My name, as I already said, is Manuel Stößel, and I'm here with Toby, a dear colleague of mine, and the head of professional services. We're both part of the professional services team at Kubermatic, and we do stuff like supporting our customers on our cloud native journey, helping them getting to know the tools and the ecosystem. And we're just generally geeking out over the whole Kubernetes stuff and the adjacent technologies. You can reach me via all the stuff you see below. Probably most stuff is happening on Twitter, so getting me there is easiest. Toby, you also want to say one more word?
Yes, thanks for having me here. Also warm welcome from my side. Looking forward to showing you what is already possible on migrate clusters. Looking forward to it as well. You see how you can follow us on Twitter and so on. And handing back to Manuel for the introduction, what we plan today. And pressing fingers for the demo gods.
Oh, yes. Okay, cool. So why are we actually talking about migrating clusters from one place to another? So there are a couple of possible reasons to actually do that. Some of them are business reasons. Could be that possibly your company got a cool deal at another cloud provider, maybe startup credits, for example, which would be the case for Kubermatic, for example, that we got startup credits with one cloud provider and needed to migrate stuff there. It could just be that some cloud provider, maybe not one of the major ones, but a smaller one that you use, has a data center migration, and you kind of just need to go with them. You maybe want to adopt a multi-cloud strategy and just diversify your kind of locations that you run your clusters at. Again, technical reasons, maybe you just want to migrate your own data center to some other network segment. Maybe there are improvements, new API parts in a new cloud provider that you want to use with your old cloud provider or your old region, whatever it may be. Or you learned that you need to be near some data location, for example, for big machine learning data sources, I don't know, huge data sets that you have to access in a certain way that maybe are more restricted when it comes to the environment. So there are loads of reasons, and we had a similar case also with a customer. We had a similar case of moving clouds ourselves. That's why we kind of got into that topic. So what kind of challenges and problems and kind of fallacies are we talking here? So Kubernetes itself abstracts infrastructure generally, but it does consume certain resources from its environment. I mean, first of all, the virtual machines itself, or the machines itself that it runs on, but it needs IP address spaces to be available for pod networks, but also for surely the machines it's running on. It needs to have routing and firewalls in place. Ingress and egress traffic needs to be managed. Somehow ingress traffic needs to reach the cluster. The cluster needs to call some other systems, or just out to the internet, right? We need DNS. We need external storage systems. Persistent volumes need to have a CSI plugin, but they still need to somehow provision volume somewhere and mount them into the cluster, into pods running in the cluster. Then there are some specific cloud-dependent Kubernetes components like the Cloud Controller Manager, right? That is responsible for updating the Kubernetes nodes and managing the life cycle of those. We have a service controller, route controllers that integrate certain parts of Kubernetes into the environment of the cloud provider itself, as, for example, the mentioned storage classes, CSI drivers in the end. And sometimes you even have a specific overlay networking that you need to use for a certain cloud provider, but a bit on the side at that point. Yeah, so just to remind ourselves, when we're talking about a Kubernetes cluster, what does it include? We have a Kubernetes control plane that runs the API server, the component that talks to etcd, the state store, the key value store that Kubernetes uses to store its state. We have a scheduler, controllers, a whole bunch of them. And the API server is the core part of the whole Kubernetes cluster that every user, every developer, every controller and scheduler talks with and effectively manages resources inside the cluster. Then we have a whole bunch of worker nodes that run the kubelet and somehow a CNI container network interface plugin that spans a pod network across all of those nodes. So when we talk migration without downtime, what are kind of then some fundamental things we kind of have to look at? First of all, Kubernetes has core networking rules that are kind of fundamental on how Kubernetes has its network setup working and expected to work. And those need to be ensured at any time, right? All containers within a pod can communicate to each other inside the pod. We need to have all pods being able to communicate with all of the other pods in the cluster. All of the nodes of able to talk with all the pods in the cluster. And the IP that each pod sees itself as needs to be the same IP then all the others see that pod as. Then we have some external dependencies that need to be reachable, right? We have external routed IPs for certain load balancers, node pod services, all of that good stuff that are kind of exposed out of the cluster that need to be reachable during the whole migration. And DNS names need to be reachable, right? Either inside of the cluster or outside. So all the endpoints with dedicated DNS names. Yeah, and then storage state needs to be migrated without data loss over several cloud providers. That is a hard topic as well. And now, if we're talking about a scale of 100 clusters or more, we do have large organizations running loads of clusters in different locations, different organizational units, different time zones. Users are generally just consumers of the cluster itself. They have access to a cluster. They just want the cluster itself, and they don't want to have a change of interface or a change of way of connecting to their clusters that they consume. Then also the cluster connections, secrets within the cluster, all of that stuff needs to be stable. So users, again, don't have to change the way they work with those clusters in the end. Yeah. So what do we think how we can solve that? It is kind of a multi-step and kind of a complex thing to do. We begin with our Kubernetes platform, which is our managed or not managed, but our management solution for Kubernetes clusters for multi-cloud, on-premise, whatever location you may have that you want to run Kubernetes clusters on. We have in this Kubernetes platform, just KKP from now on, we have seed clusters that hold the control plane of the user clusters, and the user clusters are the clusters that are managed by KKP that users then use to run their workloads, right? And we host the control plane of those clusters containerized within Kubernetes itself. We have worker nodes in those user clusters that are provisioned by a cluster API object that our Kubernetes machine controller consumes. It's a CRD, machine deployment, it's called, and then creates machines in different cloud providers for us. We use Canal as a default overlay network that is just Flannel using this VXLAN overlay network, and then the Calico policy controller on top of that, two policies. Yeah, and the whole goal of the mission is to migrate the user clusters and the seed clusters as well in the end, including the control planes, the worker nodes, and all that good stuff to a different cloud provider, right? We want to keep all the cluster endpoints stable. So we want to have all the Kubernetes API server endpoints being stable. And on the application level, we want to have all the DNS names, the ingress management stable from the user view of things. What we kept out of scope for now is the storage replication, because well, in the end, it's a very hard problem to solve, and we leave it to the application layer to kind of manage that. In our case, that is the etcd of the user clusters that will also replicate themselves right across clouds then at some point when we move the seed cluster. But anything else that is a problem to solve for now. Yeah. So how does Kubernetes in general look? Just as a quick intro. So KKP does have kind of a federated setup. We have a master cluster that holds the Kubernetes KKP control plane itself. There's some dashboard and some controllers running. Then we have the aforementioned seed cluster. In our case here, it runs on vSphere. And this one will then hold the user cluster control planes, right? The seed cluster itself, also just a Kubernetes cluster. And then per user cluster, we have a namespace. And in that namespace, we run the Kubernetes API server scheduler controller, the whole control plane components of the managed Kubernetes clusters. And then we have a whole bunch of worker nodes that I see an error in my slide here, but they're all running on vSphere. So don't look at the text, just look at the symbols. Yeah, and the plan is to move them over to GCP, right? So just some prerequisites before we can kind of think about how to do it. Announce a maintenance window and block your cluster updates. That's just being a nice infrastructure guy and not enraging your developers to a point that they might throw stuff at you. Then ensure backups and recovery procedures for your seed and user clusters, but also for your application workloads. That is kind of just a general point that you should have that in place, but this is kind of a critical those backups and recoveries work actually, and not just being dumped somewhere is important, especially in this case. So create a target cloud cluster just as a reference for the config we'll later use within KKP. So there's a cluster CRD that KKP uses, and just creating a cluster in the target cloud and then looking at this CRD to be able to kind of avoid some mistakes here is probably the easiest way to go about. Well, and then ensure that you actually have control of your DNS entries. Nothing sucks more than just having moved everything over to a new cloud and then being stuck for 2 weeks with routing everything through 2 clouds now because you couldn't update your DNS entries. All right, so how can we migrate user clusters? We have a whole bunch of simple steps that are actually altogether, I think it's relatively complex, but the steps alone should work. So first of all, using KKP, we can just create a new machine deployment in the cluster, which is this CRD that the machine controller then takes and creates new worker nodes in the target cloud, in our case, GCP, right? Then we need to ensure that those new worker nodes and pods that might run on them can talk to each other across 2 cloud providers at that point. So we will strap a VPN overlay across the whole cluster using a daemon set, and we'll route practically the whole overlay traffic, so from the CNI plugin, through this VPN network. And this works because the user cluster control plane in the seed cluster already has a VPN server deployed that we already use, so that the kubelet can talk to the API server and the other way around in Kubermatic. And then ensure that everything is reachable, right? Your ingress endpoints are reachable. The workload is moved over to the new cloud, to the new worker nodes on the new cloud provider, and applications are reachable there. And then once you checked everything, it's just a matter of deleting the old nodes and kind of cleaning up. And just to show it in a bit more graphic way, what we're talking about. So we have this C cluster here in vSphere, and we have a user cluster that also runs its worker nodes also in vSphere. And first of all, we have this VPN server deployed besides the rest of the control plane components. And we now just add a VPN client as a daemon set to all of the worker nodes in the cluster. Then there's a configuration for this VPN server and VPN clients that just routes all of the pod network traffic over this VPN server. Might not be the most performance-oriented solution, but it works well, and it doesn't really drop any packages or anything in our experience. And then you will pause the existing cluster and machine deployment resources. So the whole user cluster, the thing in the blue box, is defined by a cluster CRD within this C cluster, and there's an option where you can set it to pause equals true. That means that KKP won't try to reconcile if the actual cluster is different from the stated configuration within the cluster CRD. You just pause reconciliation, and that makes it possible for us to not kind of get disrupted during configuration changes. You can do the same thing with the machine deployment object within the user cluster that the machine controller uses to create and manage worker nodes. Then we update the cluster spec. We update the cluster CRD to the new cloud provider with all the cloud credentials it needs to then start VMs in the GCP environment. We update, we can unpause the cluster with a new cloud provider that will update the machine controller within the user cluster with new credentials and a way to be able to reach GCP. And then we can update and apply a new machine deployment object besides the old one that defines some new worker nodes in GCP. So now we have a whole bunch of worker nodes across 2 cloud providers. So now we test our new ingress entry points within GCP. So if there's like a service type load balancer or something like that, there should be a load balancer created for that in GCP. And if that works and we verified that, we can just change or update our DNS entry and let it point to those new endpoints in GCP. So once all the traffic is drained from the old endpoint, and we have all ensured that all the applications are reachable, everything seems stable. We can clean up, means deleting the old worker nodes, and also means now deleting the VPN client daemon set and the configuration for VPN in a way that we just use the normal canal overlay network again without the VPN. And that should have us migrated to a new cloud provider. And this process will, in the end, Toby will talk about also, kind of repeat for the actual seed cluster itself when we want to migrate that over to a new cloud provider as well. It's a bit different, but looks similar. All right, Toby, I think it's demo time. May the demo gods be with us. This is a complex one, so let's hope all the practice worked and helped. I'll stop sharing my screen and give it to Toby, and I'll try to keep up with questions in the chat then during his demo. I can't hear you, Toby.
Okay, can you hear me now?
Yes.
Okay, hopefully you can see my screen as well.
Yes, I can.
Okay, perfect. So before we start to migrate, I just want to give you an introduction how the current setup looks like. We have a Kubernetes setup. We have here a project in Kubernetes where we host multiple clusters. So in this case, we have a few clusters here, and we want to migrate this one to the Google Cloud. And for now, the demo is reflecting this cluster, and later on we'll show you how we can migrate also the hosted control planes in the seed cluster to another cloud. Here we see we have now here a traditional Kubernetes cluster with API server, etcd, machine controller, scheduler controller, and user controller manager, and here 2 additional vSphere nodes, what running in our small tiny vCenter in our office. So here we see in the vCenter also the nodes are running here just as original VMs, and this one we want to migrate now to the GCP cloud. How we can get started? First, we need to get a workload on it. For that, I will deploy now in the first step an Nginx ingress. So to have 3 pods and then install the ingress component, and for on-premise we need kind of load balancer in front of, so we're choosing metal LB for this bare metal for the on-premise load balancing, so therefore we need a virtual LP. Come on. Okay. Right. Specify the range so that we only get one external IP for that. Install it. And last but not least, we want to also install some workload. For that, we have a small tiny echo service application which just returns something. So also giving 3 replicas of it and the ingress path echo. So let's install that one. and see what's happening. So we have now 3 components for like similar like in a real workload. And open, and if we go to the dashboard, we would now see that we have the application also reachable by this external endpoint. So it seems that my screen sharing is slowing everything down, but I think we will get that. Okay, so here, if we go now to the ingress namespace, we see now the Echo Server namespace, the Nginx ingress namespace, and the Metal LB namespace would be there as well. Here we have the ingress Nginx running, and we have the also should have the service where we can connect now. And we see, okay, Nginx is running. And if it goes to /echo, we get now this tiny little JSON payload back, what gives us the indication that the application is still running. Okay, so far so good. We have an application and now can also connect to the cluster over our kubeconfig to have this running. So here to show that it's running, here we have our watch loop, what delivering us back our workload. Here we have our master control plane where we have the cluster CRDs, where here we see our clusters have a state. We can describe the cluster where we see, okay, what is the state about? And see here our description. We have a status of the components. We have a description. Okay, we're running here in vSphere under this folder, and that's the setup of our cluster and so on. So that's how we manage in the backend the Kubernetes cluster. And we can now go to the namespace and see our control plane components running. So here we see every component, the API server, the controller manager, the etcd, the Kubernetes dashboard, the machine controller, what's talking to the vSphere API to provision the machines, and so on. And also our VPN server. This is default deployed because we are opening a VPN server to have a channel back to the workers. So the workers open a VPN client here in the master control plane, and then we have a tunnel back to get the kube control logs. So to connect now the end cluster, I can use my kubeconfig, what I downloaded recently, and see here now in the user cluster, there get nodes. The 2 nodes running. Okay, so first step is now to really start the migration. I just start right now the migration, then spanning the VPN over all nodes just to save a little bit time. But you can also deploy the VPN before you provision a new VMs. That's up to you. So herefore we have a little bit of a helper script, what I just prepared to hopefully get the demo running. So first we want to change now the control plane components to talk with GCP correctly. Therefore, I need the script. What happens now is I need to add a cluster ID and a project ID so that we can migrate the right cluster. We have this project ID, and then you see also the projects are CRD in our Kubernetes setup, and we need this project to migrate it. So what's now is first we want to back up the current cluster definition. So we store this file as a backup and then pause the cluster. This pause flag caused that our cluster controller who managing the cluster lifecycle stop updating the cluster and reconciling the cluster loop. So yes, we want to pause it, and now we want to patch the cloud provider. So and therefore in the first step we just remove the existing cloud provider in this 2-step approach. So if we go here now, we have now our cluster backup, And we can delete this too, this is the old ones, and see now the diff of that one. So if you go here, so we removed the metadata, what we don't need, and we removed here the specification of the YAML, the credential reference, what's internally connecting to the vSphere credentials, and the infrastructure management user, and so on. And we set the cluster to pause through. After we apply that, we will see that we patched it, and we can then unpause the cluster, starting a reconciliation with the new specification. So that's something what later on is planned in the status to automate everything by an operator. Currently is a fancy bash script, what you find in the GitHub repository. And we can then transfer that to real, like, on scale level of operator. Here we see now the control planes are running, and we can move forward now to change the GCP in the next step. So again, pause the cluster and patch the cloud provider. What you're now seeing is that we create a new secret. So we need to somehow to render in the credentials for the new cloud provider. What is in GCP case a service account, what I created before. So yes, we need a new secret, and that's get created in the C cluster. And as then we patch the cloud providers back, and we can double check now how does it look like. So we see here we changed here the data center to the GCP data center. We change the specification of the cloud provider and exiting the new credentials. These credentials are really not something special. If we go here in the template, what we render here, we see that's only a generic Kubernetes secret, what's holding this service account base64 decoded. And here you see the patch, what we applying for the cluster specification. So nothing, not too much to change here. Everything else is already done by our controller. So in the next step, we now see that our cluster get reconciled. We updated it, and we unpause the cluster. So now the cluster controller of Kubermatic does start the reconciling loop and changing the cloud provider behind the scenes. So we see here now our new spec of the cloud provider. We have here the network already assigned. That's the default network because we didn't specify it. And we can now watch that we have a rolling update of the cloud controller components. You see the API server restarted, the controller manager restarted, and that's the control. Now the change of the control plane components is processing. After this is finished, we now can talk successfully with the Google Cloud. Here we see also the machine controller get restarted. Controller is not pointing anymore to the vSphere nodes. It's pointing to the GCP to provision new nodes. Nodes are still there. You can see they are ready. Nothing changed here. We see also application is still reachable. Okay, cool. Next step is we need the metadata for the later on machine deployment. The machine deployment is the cluster API project for object to manage the machines based on a Kubernetes custom resource. And the only thing what we need later on is the cluster ID and the project ID and the network. So now we're starting to roll out the VPN overlay. What now happening is we patching our VPN server, and for that we need to pause the cluster reconciliation. We patched the VPN server that said that the VPN server enables client-to-client communication between all clients. And now we see that the server get restarted here. And in our current implementation, this is only one server. To make it really high scalable and also for bigger workloads, we would need to engineer a little bit more, that we have really also an HA VPN server for managing that, or using something like Wireshark in the future. After this is now restarted, we can roll out the new machine deployment. And that happens from the user cluster scope. So herefore, we creating the new machine YAML. So just to increase the size a little bit, to showing what is now deployed, we have the machine deployment, we have a machine set, and we have machines, and we have nodes. So here the loop is, sorry, I need the kube system namespace.
Toby, very quickly,
Yes.
can you increase the font size like one step? I think some folks aren't able to properly read it.
Okay, I try my best. Okay, so here you see we have one machine deployment specification, what's similar like a normal deployment. This matching a set, a machine set, and a machine set managing a set of machines. Here we see that's the IPs of the vSphere data center, and that's matching then a node, what is replicated there. What we're now creating is a new machine deployment for the Google Cloud. And for that, I also prepared a script. So let's start the workers and machine deployment script. To first, we need to pause the current machine deployment. That means that we don't update that one and keep that out of the reconciliation loop. So yes, we want to pause the vSphere migrate pool. Yes. Okay. And then next step, we creating the new worker nodes. Say yes. So we now need the cluster ID, what we created before. So we have the cluster ID, and we need a project ID, and now can create a new machine workers and say, yes, we want to create. Yes, it's paused, and we see here the new machine deployment. This is everything what get now applied. So we have a kind machine deployment. We have a specification. We want to start 2 machines. We have a cloud provider spec where we say, okay, that's the type. We want a SSD. We want this machine type created at Google Cloud. Then, yes, applying it. And here we also have my SSH key that I can log in. And now we can watch machine deployment creation. Here we see now, okay, we have a machine deployment that's created a new spec of here Ubuntu GCP target. We create a new machines. That's the 2 machines, and if we now go to our Google Cloud Console, we can see that the new machine should be immediately created. So loading. Right, here we are. Also increasing the size a little bit. And you will see here that we have new 2 nodes provisioned here. That's the nodes where what we got. Here you can compare the IPs, will be also then showing up here in our shell later after the nodes get assigned, and we have the new GCP nodes. So that's the one I created before. And we also will see this in the UI. So you see already that we changed the cloud provider get changed. We see the new machine deployment is coming up here, and we get here as well the informations about the new nodes. So after 1-2 minutes, they will be up and healthy. Good. Then, yeah, we just need to wait a little bit, but we can already continue with now the next step would be that we deploy the VPN overlays to the nodes. Okay, let's see if the nodes are now healthy. Yes, cool. So you see now they are booting. They are not ready and getting soon ready. And as soon as they are ready, we can have now a cluster across 2 clouds. What is not recommended for long term, but we could use that for during the migration. Cool. So then let's strip over now the VPN overlay, worker, VPN overlay, deploy. So what's now happening? We want to deploy a daemon set. What? Oh, again, deploy a daemon set. What creates now a VPN interface on every node? And yes, I don't want to restart it because it's the first time I apply it. And we see now that we created a VPN client on every node and should be able now to communicate to each other. To test that, we can just SSH to both nodes and see how this is running. So let's open a new shell to make it clear. SSH Ubuntu and connecting here to a GCP node. Yes. Yeah. And we see a lot of IP addresses deployed. So from the Docker, from the Kube IP, Flannel, and what's most important, that's Kube interface, what we created over VPN. So that's the GCP worker. Now let's connect as well to the vSphere worker. For that, let's go back here to get the IP of the vSphere pool, one of the nodes. And yes, here we got just the route controller of the cloud controller can for sure not reach that. That's why we get this warning. What currently is not a problem because we are during the migration. Then here we go. And now we are here on the vSphere node. And as you know, we cannot ping here this IP directly. So here, that's the public IP. If we ping that one, we could not reach it. We can reach it, but directly, but we can also now use the channel. The other way around would not work. IP. So sorry for the wrong direction. I could not ping this internal IP because it's only in the private network of our on-premise data center. Okay, you cannot reach it, but we have here in the worker node as well, we have here the IP address of the VPN interface. That's one we can reach. That we are using then for the canal overlay. So we see here we're getting now an interconnected VPN between GCP nodes and Ubuntu. Next step is now to deploy the canal overlay and restarting the overlay. So for that, we update the canal config to use the VPN interface. It's a small patch. And we then file the patch and we're restarting now the canal overlay. Okay, cool. So you see the rollout is step by step, so that still is stable. After all get restarted, we can then migrate the workload. Good. So that's working. And then next step is to migrate the workload. Yes, that we already checked, that we can talk to each other per VPN, and we can now migrate the workload. So what's happening now? First, before we moving the cluster, we want to taint the old nodes. So let's keep that running, that we see that's. So we have these 2 nodes, and now we want to taint the old ones that they don't get new workload. So now they get cordoned, and in the next step, we then reschedule the workload of the Echo server. Echo server workload is now running on vSphere, and we're migrating it now to the GCP node, as you see that the container are get created right now. Okay, so it's still reachable here, or also from the browsers must be reachable during the migration, that we get still the application workload running, and now every Echo server container is at GCP. Cool. This worked. Next step is then to migrate the ingress, and yeah, we saw that it's still reachable, and now we can migrate ingress. Sorry, wrong button. Okay, so now rescheduling the ingress workload. Yes, and here we're doing the same principle. We serving now, we migrating the workload step by step, one by one, to the new cloud. Then, yeah, apply the second ingress to see, okay, to get reachable the new ingress controller, and that we can test then from the applied load balancer. So we see here the service get exposed, the IP is still pending, and we can check here curl of the node port at least should be working already. Then I just need IP of a public node. Here we are. Good. Here we are. And we can curl here and see, okay, we can reach also the service now over GCP directly. Cool. So next step is to getting a real load balancer there. For that, we need to remove the on-premise metal LB. So now the workload is migrated, and we can get our cloud load balancer. For sure, it's also possible to create before like an external load balancer who can manage traffic outside of the data centers. And yeah, we need to remove the metal IP add-on also from the cluster. Otherwise, it gets reconciled. That's what we don't want. And delete it. Yes. We're done. And creating the new service. And after a few seconds, we should be able to then have the old service deleted. and now unpause the cluster as a final step. And unpause cluster, our GPC webinar cluster, unpause. Yes. Now the VPN server get reconciled, so it's get returned to client communication. We can restart cloud controller management to get also that's the cloud balancer. And we then can on the client side remove the VPN again and using the canal overlay. So we now returning the canal overlay. Original interfaces again. So we switch them now back the VPN to the original configuration, what is now running on GCP. Cool, this looks good. And we can remove the daemon set. And then we should see that we also get here that removed. And we can drain the nodes to like migrate the missing pods and evicting them. And potentially could also delete the nodes as final step. Remove the nodes. Cool. Yes. So now if we go in the ingress namespace, we should also get finally the external load balancer IP. Okay, still pending. But sometimes this updates takes a while, but we should see in Google Cloud that we now getting also the load balancer attached. Yes, so hopefully this is reachable already. And okay, just takes a few more minutes and we can go back then later. And we have a new public IP load balancer. Okay, so going back to the slides, how we can now migrate also the user cluster control plane. So in this case, we migrated the workload successfully to the cloud. You can take a look in the scripts and so on, how we did it. It's more the next step would be to create an operator around it. So as you see, we have now here migrated the user clusters. We have the control plane still on premise, and we can that now migrate to GCPs as well. In how we can do it now. For that, we need to have two steps. We need to master nodes at a new cloud provider, getting a new Kubernetes API load balancer for that, and need to update the DNS endpoint. For that is for reverse case recovery is recommended to also block the C cluster upgrades so that we don't create there any changes during the migration. The next step is then to migrate the user control planes. As we run that containerized, we can also ensure about HCD application localization that we get the data from one cloud to another. So how does it look like? So here, now that's the current setup. We have the containerized control plane was talking to GCP, what's running a GCP cluster. Here we have our master control plane with different HCDs, and we have the worker for in vSphere. Now to migrate the C cluster master, we can create two new GCP masters, having then 5 HCDs with a quorum here created. So that means that this also the replication of this HCD data by our application. If we now span a VPN over it, we can use the same approach as before. To switching now over, we need to do it in 2 steps. So just removing 2 nodes that we have still a valid quorum, then reducing the size of the HCD ring to 3, creating a new GCP master node as well that get as well replicated by the HCD application. and having then a new healthy master in the new cloud. Also, the nice thing of this approach is the user clusters are not affected so far, because everything here runs on the worker nodes, what is completely separated from the traffic and the control of the master of the C clusters. Cool. Then next step is to migrate all the C cluster workers, what's holding the end clusters control planes. For that, we have here an endpoint, what's matching also an DNS entry, what's going over a load balancer to the dedicated workers. In the normal case, each worker has an etcd volume attached for each clusters. So therefore, we're using a node anti-affinity where we spread the etcds across different worker nodes, and to ensure that that don't hosted on the same worker node. The next step is here, as well as we do that for the application workload, we do it here for our application workload. What's the control planes? We're creating new nodes. Then we don't roll out and restart the workload. We just increase the size of the etcds to 5, what we can do by a property. And then etcd automatically also synchronized data here for the 2 additional workers to that GCP cloud. Next step you can think about is changing load balancer. So then the user cluster worker nodes, kubelets, reaching a new endpoint and connecting over this new channel to the new GCP based etcds. Last step is then adding a new GCP worker, replacing one old of the vSphere, and then we have the quorum at the new cloud, and then we are successfully at the new cloud because we need a quorum of 3 or 5 to have a healthy etcd. Then last but not least, removing the old etcd workload, the cluster scheduler ensures that the etcds get moved completely to the new cloud. And last step would be to remove the additional replicas and reduce the replicas again to 3 etcds. Okay. So we mostly on the end. And what is next? So as you see, the cleanup is partly automated. So there's an idea to switch back the cloud provider, deleting the old stuff, and then switching back again to the new cloud provider, what we could do via an operator. So the next really final step is to get the time and a project to build the operator, what can do everything what I did by hand, by an operation manner, what is tested, what can be implemented with health checks and wait conditions. As you see, I migrated one cluster in around like 15 minutes. Even if I would do it fast, it would be maybe 10 minutes. It's now the option that we really can scale up this migration step by step. In an example, currently at KKP, we're upgrading like 100 clusters by 10 clusters a time. And that's could be a same approach. We can migrate clusters. So we just doing migrating cluster by cluster by an operator-based workflow, and the operator can then stop if something goes wrong and keep the state. So that's our next plans. To have defined health checks where we have the waiting condition. Okay, now we are migrated to step. If something fails, please stop. Then the operator can get like a real operator person can get an alert and see if something is breaking between tests. As already saw a question in the Q&A, for sure the VPN connection is currently not like reliable for a hard workload, and it should be also like stabilized. It means we need multiple VPN server, and we need a really soft switch over VPN and host network overlays. That's something what we evaluate. Is there Wirecard maybe help us there? And also to clean up and manage the load balancer DNS management, that like a controller or an operator as well can manage the load balancer to get created in the right time, and updating the DNS also in the right time. So that's are the steps what need to create it. But I think for a POC, we are in the state that we can say it's possible. It's possible to really migrate 100 clusters in a matter of hours and not in months, and that we are flexible, move workloads between clouds, and that we can build like also trust on the platform that we can move the workload between data centers. I mean, we now move workload between clouds, but we can also use the same approach to move maybe from one data center to another data center in the same cloud or on premise. Okay, then I think it's time for questions. So I don't know how much already answered.
I answered a few, a couple of them, and I'll answer another one, I guess, right now. So a question about downtime when switching over load balances, so effectively DNS entries to the new load balances, with clients having still DNS responses cached. I think that is ultimately true. I think the only way you can kind of avoid that is by effectively waiting so long as in the old, that you look at the old load balancer, if all the traffic really drained from that and there are no more active connections, and then switching over. But that is effectively, well, that's the only way to do it anyways with DNS, right? There's really no good way to otherwise do it. Well, and beforehand, I mean, setting the TTL to a reasonable time, right?
Right. And maybe you can place, like, before you start the migration, like a kind of global load balancer before, where we just like have a stable IP outside and then changing inside of the load balancer the dedicated endpoints between the two clouds will be also an option, but it's a little bit out of scope of the in-cluster migration.
Yeah, then there was a question coming up several times, so I'm going to repeat it here, I guess. If we can migrate persistent volumes as well. I answered it until now that we can't. Persistent volumes generally are just a representation of an object that is not managed by Kubernetes itself. So it doesn't replicate throughout a Kubernetes cluster, just like, for example, a pod would, right? Although, yeah. So this is really just a representation of a very cloud provider specific storage implementation in the end. There's, at least for now, no good way to replicate that, I guess. So we would rely on the application layer to replicate, like etcd, for example.
I mean, we cannot say it from our perspective, but like cloud storage vendors offer sometimes replication between clouds. Yeah. If this is the case, it would be possible, but that's something where we are not the storage experts, so we think it's better than to talk with the dedicated storage vendors. If there's storage vendors supporting that kind of like replication between different locations would be possible.
Yeah, then Tigo Marcel is asking if we have some blueprint documentation to approach similar problems. We don't necessarily have a blueprint documentation besides the slides and a GitHub repository with all the scripts and stuff. But so that we do have. I think, Toby, you can switch to the slide, I guess, with the link again. It's github.com/Kubermatic labs, Kubermatic-labs / and I forgot it. I think it's cluster-migration, something like this.
Kubermatic labs, if you go.
I'll post the link in the chat, or you do it, okay.
And here you see cluster migration. You see all the scripts. So it's not really, it was just for more preparation. And here we go, in the post in the chat. Here,
yeah.
the Q&A.
Then a lot of folks were asking about if and how we would and how well we would handle big data migrations over the VPN. And well, in unison, I answered usually that well, it depends. It depends on the VPN itself. It depends on the effectively on the internet connection between the two cloud providers, right? A small, tiny data center, very local, very on-prem, that might actually be an inhibitor here. And then, yeah, I guess the VPN connection and the VPN server itself are the kind of the bottlenecks here.
Yeah, as we containerize the VPN server, you can like just deploy by default an HA containerized VPN server to ensure it. But yeah, for sure, that's more a question to tune the VPN. As we said, that's like currently we did that in a POC scope. So to prove it in general, the concept, next step would be what to bring that on our roadmap to develop that in a like for massive workload migration. But as VPN is still like one of the stable products in cloud native, and it should be a way around it, and maybe WireGuard is a better solution, what can help there. But first of all, the idea is to using such layers be underneath for a connectivity during the migration, and just should be only for a short-term time. So it's not recommended to run this setup like for multiple days or something. It should be only like during the migration. And if you really have a case like that's a question about Submariner, I think this to connect to Kubernetes clusters on premise in GCP, that is also a case that you can like manage this way a migration. But if you have really the need like to moving dedicated clusters to another cloud, then this would not work. So it's a few approaches around, but everything is mostly related to net connectivity or networking, and to ensuring that you have a healthy cluster during this time.
I'm afraid that I need to interrupt now the Q&A session, but we are running out of time, unfortunately. We still have some open questions, I guess. But before we get kicked off the meeting in a nice way, I'd just like to say a few closing words. And you still can ask your questions. You can send us an email to marketing@kubermatic.com, or you can reach out directly to Toby and Manuel to go through your open questions. Thank you very much for joining. Just very short on our own behalf, we are going to host a joint webinar together with our Australian partner, Kubermatic, on February 23rd, very early in the morning, 8 a.m. Central European time, and the topic will be Empower Your DevOps Organization with Kubernetes. I'd warmly invite you all to join us, so it would be great to see some of you there as well. And last but not least, we are hiring. So if you're a Kubernetes lover, if you're ready for a new challenge, check out our job openings, see if there's any matching position. And if not, send us your CV and we will see if there's any job opportunity we could offer. Yeah, and we are happy to get some more followers on our Twitter account, to receive some more GitHub stars for our open source projects. So support is always highly appreciated. Yeah, but that's enough marketing stuff for tonight. Thank you very much for joining. I hope you could learn something in this session and that it was informative for you. Yeah, thank you very much and have a nice evening.
Yeah.
Thank you so much, folks.
Thanks a lot.
Bye.